Hello everyone, welcome back to the channel. I hope you guys are doing pretty well. So we will see this problem for today and we will try to solve it together. So let's see the problem. I hope it's an easy tagged problem, so it should be quite easy. Uh, Minimum changes to make an alternating binary string. You are given a string consisting of characters 1, 0, and 1. In one operation, you can change any 0 to 1 or vice versa. The string is called alternating if no two adjacent characters are equal. So you can see 0, 1, 0 is alternating because no two adjacent characters are equal here, but 0, 1, 0, 0 is not alternating because you see a last double zero at the end. Okay, so return the minimum number of operations you need to make this string alternating. So in this string, if you see, you can make it alternating by just changing this 0 to 1, right? So you will have uh, 0, 1, 0, 1, and the whole string is now alternating, and therefore you need only one operation. Okay, one operation is defined as changing 0 to 1 or 1 to 0. This is already alternating, so you do not need any operations. You can return 0, right? And for this string, if you see, you can change this 1 to 0 and this 1 to 0. So you need two operations to convert it into 1 0 1 0. Okay, now you might be thinking of one algorithm, right? We can iterate through the string, and whenever we see that the character is equal to the previous character, we can just change that particular element of the string. Similarly, you can think for this one. Okay, so what I'm trying to say that it is very tempting to think of an algorithm something like this, that hey, I want to change this to alternating string, so I can iterate through this index, this index, this index, and at this index I will find that it is equal to the element in the previous index. So I will change this element. Okay, 0 1 0 1. Again, then I require just one operations. When you are thinking of some example like this, again you can think that hey, when I am in this position, I will see that it is equal to the previous position, so I will change this to 0. Then again here I will not observe that, but here when I will go, I will observe that again this element is equal to the previous element, so I will change this 0 to 1. So a total of two operations I am able to convert it to 1 0 1 0, and therefore the answer is 2. But this is actually a wrong algorithm. Okay, it is very tempting to think, I do understand, but it is important to understand that this is a wrong algorithm. Why? Consider one example, something like this. Okay, what you might think here, what do you might think here is that let's see, let's try to apply that algorithm. You are in this index, no problem. This index, no problem. You are in this index, and you will find that these two, it is equal to the previous index. So let's change that. So in one operation, you got something like this. So again, when you are at this index, no problem with this. No, this index you see, again, it is equal to the previous index. So you try to change it to something like this. Okay. Again, at this index, there will be a problem. So you try to change it to something like this. Again, at this index, there is going to be a problem. So because it's equal to the previous index character, so you change it to something like this. Again, you see at this index, there is going to be a problem. So you can change it to something like this, and you see nowhere anywhere else you will be a problem. And you might think that this is one operation, one operation, one operation, one operation, one operation, total of 5 operations. You are able to get the final string, and you might realize that hey, I am done with this. Okay, but you see there is even a better solution for this. There is even a better solution for this. What is the better solution? I am writing in green. So if you are having this string, what you could have also done is that first change this 1 to 0. Okay, you will get something like this. Then change this 1 0 to 1. You will get something like this. Then change this 0 to 1. You will get something like this. And at the end, you see that you got an alternating string in just 3 operations. But this method was not at all intuitive. This method was not at all intuitive. So what to do? So one thing you definitely observe that uh, given a binary string, so if you are given some binary string consisting of something like this, there is only, or something else, okay, there is only two choices of being alternating. One, it can become an alternating string of something like this, or it can become another alternating string which looks something like this. So what is the difference between the two? One starts with 0 and one starts with 1. Okay, so one is of the type 101010, and another alternating string is of the type 010101. So of the all possible strings, you see there are only two alternating strings possible. So there is no other answer possible for that. Okay, so you can just see that how many, to get this string, how many operations we require. So you see that this element is equal, this element is equal. So for changing this element, you need one operation. Changing this element, you need two operations. Changing this element, another operation. Changing this element, another operation. You can just check that how many operations you take. Okay, so you can call this answer one, or you can call this, let's say, start with one. Okay, and similarly, you can count the number of operations required to obtain this string. At every position, you just iterate and see that which all digits need changes, and you just add to your answer, and you can call this start zero. And of course, the minimum one you need to return. Since you have only two possible choices, out of these two choices, whichever is minimum, you just return that. Okay, so it will be as simple as that. So yeah, if you think it in the correct way, this problem becomes really, really easy. And a single pass is also feasible to solve. I will write a single pass solution. So let's see. Let's see. So idea is the same. I will have two things. Let's say start with 0 and start with 1. So after this, what can be done? I less than s dot size I plus plus. So you see, uh, one thing you can observe that if a number starts with 0, so if we are having this answer at, see, this is 0 index, 1 index, 2 index, 3 index, 4 index. So at every even index, there has to be a 0. If it is not, you just increment by 1. You just increment the answer by 1 because you need to make changes, right? So if I module 2 equal to 0, if it is an even position, okay, if it is an even position, and s of I, if s of I is equals to 1, okay, or you call it is equals to 1. So at even positions, a start 0 must have zeros, right? But if it is 1, you can increment the count of start 0. Else, you can increment the count of start 1. And if the position is not divisible by 0, okay, and then if s of I is still 1, you can increment start 1. Else you can simply increment start 0. I hope you do get what I'm trying to do. That, yeah, at every even position there must be a 0. So if there is a 1 for start 0, let's increment start 0, because that is start 0 represents the number of operations that we need to change the string to a string of the alternating type 010101. Okay, so it starts with 0. The final answer should start with 0. And again, if a string is starting with 1, so at every odd positions, so if a string is starting with 1, at every odd positions, it will have 0. Okay, so if it is having a 1 at the odd position, you just try to increment start 1, else increment start 0. I hope this is very simple, and you can just return minimum of start 0, start 1. And if you try to just submit this, I hope this will work just fine. Yeah, you see it worked fine, and it also gives 100% runtime bit since it is a single pass solution. So I hope the approach was very clear to you. There should be no doubt in this. It's a really simple problem if you think it in the right direction. Yeah, so that's all for this video. I will meet you in the next video. Till then, thanks a lot.